right, guys, let's see if you got the answer correct. What did we want to find? We had the gradients of AB. We worked out that in the previous part. We know the gradients of AB was 1/4. We want the equation of CD. We've got a 0.14 on that line, but the property of perpendicular lines from the grade 10 year, which you guys will see, is going to be, and this is now for grade 11s, grade 10s, this is new to you. And the tricks, you must know that the product of the gradients is -1. So if you look at this, the gradient of CD is -4, which we had. What's -4 times 1/4? Is going to be -1, and that's properly. Now we've got everything we need. We've got the gradients of the line, and we've got the point C on the line. So what do? There's C as your x1, y1, and we can plug it in. Now remember, this is going to be x1, y1. Yeah, that's x1, and that's y1. So in other words, in x1's place, you'll put a 1, in y1 a 4, and the gradient is -4 there. So watch out for that, it's pretty cool. Okay, now let's see what do we get. Okay, so then you say y -4 is equal to, that's the x, the y1, m is -4, and the x1 is 1. And all you do is you multiply out, bring that across, and you have -4x plus 8. And that's the equation of that line that you want. Okay, cool. Let's have a look at this one now. Here's another version. We've looked at CD, and now what we want to do is we want to find the equation of the line through D, this one, parallel to AB. Now remember, people, this is so important. You already know the gradient of AB is 1/4. Now what do you know about parallel lines? Yes, someone said it there. You have equal gradients. Good. Okay, I'm loving this. So what do we know? We've got the gradients of AB. We've got that gradient, so we know, and we've also got the line y equals, this is the line CD. Okay, we've got that. We're going to use that in a moment. You'll see. Because listen, if you've got the gradients of AB, hold on to that. We know the gradients of the line through D there, parallel. The parallel lines have equal gradients, but we don't have a point on the line, this little line here. So we're going to maybe need, but we've got this equation of CD that we used, that we worked out before. Okay, now watch this. An important concept here is that parallel lines have equal gradients. The gradient of AB is 1/4, therefore the gradient of the line through D parallel to AB is equal to the gradient of the line AB. Okay, so they're equal. So now we know that the gradients are the same. Okay, we now need to find a point on the line through D parallel to AB. It is clear that D not only lies on the line through D parallel to AB, it also lies on CD and is the x-intercept of that line. And we're going to let y equals 0 in the equation. Now have a look here. If you look at the equation of CD, that's what it is. Okay, we worked it out previously. If you let y be 0, and you solve for x, you're going to have the point D being 2, 0. Now that is a point on the line. Okay, now let me go back, and I just want to go back to the graph, and let's see. So what do we now have? Remember, what did we do? We've got the gradients. Let's just summarize this. This is important. The gradient here is 1/4. So the gradient of this line is also 1/4 because these lines are parallel. Okay, we need this point. Okay, and how did we do it? I'm going to get a little bit of a different color here. We took this and we put the equation. Remember, this is the equation of this line, equal to 0, and we solved for x. And this is the point 2, 0, which is on the line, and that is x1, y1. So we've got a point on the line, and we have the gradient of this line. So if we do that, we're in a position to be able to find that equation. Okay, and if we go back to the new slide here, we can find the equation of the line through D parallel as follows. There's your point on the line, we've got the gradient, and we've got our equation of the line. So again, y1 is 0, there it is, x1 is 2, and you've got your gradient. What a pleasure. And then we simply, that vanishes, 1/4 x, and remember, 1/4 times 2 is 1/2, and there's your equation of that line. Perpendicular lines, If you multiply the gradients, you get -1. Parallel lines have equal gradients. Okay, so that's important there to master, okay, in this thing. So watch out. So what have we done, people? Let's just quickly summarize a few things here. Okay, if you've got two parallel lines, the gradients of the one line and the gradients of the second line, the gradients are equal. But if the lines run perpendicular to each other, M1 and M2, if you multiply those gradients, you get -1. And remember, if you want an equation, say you've got that gradient, you need a point on the line, which we call x1, y1. And this is the equation of the line that we're going to use. You could also use y equals mx plus c, but I prefer to use that one on Matrix Uploaded. So let's go for it. Okay guys, stay with us. In the next lesson we continue with analytical geometry.